let's learn about domains, codomains, and range. So the main concept here is about codomains because that's a new concept that we didn't learn about before. So let's say I was given a function. Let's call this f of x. And we all know that the domain basically means, so domain is the domain is a set of all possible x's. So any number in this domain can be the input of f of x. So the domain is a set, and the domain is a set, and it contains all possible inputs of x. So anything that can't be an input of x is not in the domain. And the range is, the set of all possible outputs, and it's based on a domain. So anything that can't be an output of f of x, is not in the range. Now, what about codomains? The codomain is here to limit the range. So the range is a subset of the codomain. So why do we need codomains, and how does this actually help with anything? Because many times people just think that the codomain makes things more confusing. Like, there was a domain and a range, and these are really precise and accurate, and then there's a codomain. Like, what's the codomain for? So I'm going to tell you in this video. So the domain, the domain, as you know, can be defined. The domain can be defined. And so it's part of the function's definition. If you change the definition of the domain, you change your function. If fx and gx have the same equation, but their domain is different, then they're different functions. The range is not defined. It's based on the range. It's based on the domain. It's based on the domain. You can't define the range. You can't go like, my domain, so in the function like fx, when f of x is equal to x squared, and I define the domain as, I define the domain as x is a real number, then and it's obvious that fx is going to be larger or equal to 0. That's just the range, because anything that is a real number is the input. Any real number inputted will result in the output that is larger or equal to 0. Every single number that is larger or equal to 0, that is a real number, is a possible output of the function. So do you get it? Like, any number that is not an output of the function cannot be in the range. So every possible output is inside fx larger or equal to 0. Every possible output is larger or equal to 0. Every real number larger or equal to 0 is an output. So basically, this is the range. The domain directly influences the range. You can't change the range, but you can change the domain. So if I change the domain to say that x is now larger than 3, then my range will change to fx is larger than 9, because that's just how it works. So given the domain, any number that is a real number and that is larger than 3, if we input it, we get, so every possible number here larger than 3, if we input that into the function, we get a number that is larger than 9. And every number that is larger than 9 is a possible output of this function. Every possible output of this function with this domain is larger than 9. So, do you get how the range is the precise output set of a function? So it contains every single output without any extra non-output related numbers inside the that's the range. So the codomain is different, because the codomain is essentially like the codomain contains all possible outputs of fx. However, it also contains some numbers that may or may not be the output of f of x. So you can say the range is a subset of the codomain, because let's say f of x is larger or equal to 0. That's the range, right? I can limit the codomain. So I can limit the codomain as f of x has to be a real number. So I can use the codomain to limit the range. So now if I said that my codomain, so if I change my codomain as, so if I decided that I change my codomain into f of x is larger than 0, then in this case my range will have to change, because my range is a subset of the codomain. So the codomain is also defined. And the codomain also influences the range. So the codomain is defined, and if I define f of x is larger than 0 as my codomain, then the range has to change. The range can't be this anymore. The range has to be f of x larger than 0. So for here, if I define f of x is larger or equal to 9 as my codomain, my range is okay, because it's still a subset of the codomain. So do you get how the codomain can be defined? It's part of the definition, much like how the domain is part of the definition, and it limits the range, like the domain limits the range. However, the codomain directly limits the output, and the domain limits the input. The codomain's like, okay guys, the output is gonna be in this range, or this inequality, right? And the range will be the range will be part of this codomain. Now the domain is limiting the input, and the input is something that is so the input actually partially influences the output. So I hope you get the concept of domain, range, and codomain. Thanks for watching.